All right. So now that we've actually seen some proportions, I want to run down a few different applications. One application is what we call similar figures. This is sort of a geometry application. Um, Similar figures are essentially sort of scaled up or sort of scaled down versions of the same shape or figure. So, for instance, I should probably just like sketch one. So say we've got just like a kind of a right triangle. This is maybe sort of our classic kind of 3, 4, 5 right triangle. So 3 inches here, 4 inches here. And just next to it, what we have is essentially, you know, a version of the triangle that we sort of shot with a grow gun or something. These don't exist. I was gonna say a shrink ray, but whatever the opposite of a shrink ray is, because it's bigger. So maybe the side that's 3 inches has now sort of jumped up to 5 inches, and we'd like to know, you know, how big is the side down here that was 4 inches. So the idea is that these triangles are effectively the same shape. It's just, right, a bigger version of it. And so what we can do in this instance, right, if we're kind of told that these are similar figures and they kind of have this property, is we can relate all of their side lengths with a proportion. So what we're going to do is you're going to match up, in this case, so the 3 and the 5 are kind of on the same level. So we can say, right, kind of 3 inches. And then on the other side, we can put our 5, right? So we'll do kind of triangle 1 on the left and triangle 2 on the right. So the 3 and the 5 we kind of want in the numerator position, and then we'll compare that with, so 4 on the bottom, and then our sort of x value is over here. So that's the setup, right? Just sort of getting our proportion, and the whole idea is you just want to sync sort of top to top with the same sides, and then sort of bottom to bottom with the same sides. To solve it, right, to find the x, we're just going to do our usual cross multiply, right? So this would be 3 times x equals, right, 4 and 5. I'm going to kind of ignore the units for now because everything here is inches and inches and inches, so we don't really need to be tracking them really closely. And so what's left? So this is going to be, you know, not an even number. Our x here, you know, 20 over 3, or did we have that number in one of our previous videos? This is like 6 2/3 inches. Right. So this is just sort of a scaled up, a slightly bigger version of our triangle here. And you know, you can do this with all sorts of different shapes, whatever kind of shape you want. Triangles, obviously rectangles, rhombuses, you know, whatever you got. You can do similar figures of it. Another sort of application might be, you know, kind of more generic. I always think of these like cooking kind of application, these like recipe applications. So say the recipe calls for 2/3 of a cup of sugar for this particular recipe. And so maybe that makes whatever, 10 donuts. Is that realistic? I have literally no idea. And so then I need to know how much, oh, excuse me, sorry for that, how much sugar to make 25 donuts, right? So I know 2/3 of a cup of sugar will get me 10 donuts. I need to sort of scale this up, right, to be able to make 25 donuts instead. So what I can do is I can create a proportion. I guess it'd be kind of a proportion of rates here, right? So the idea is you've got 2/3 cups gets you 10 donuts, right? And so then the question is, so X many cups will get us to 25 donuts on the bottom. So again, the whole idea is you're trying to sort of match up and sync, right? Donuts to donuts in the denominator, and then sort of cups to cups up top. It's kind of arbitrary which values, sugar versus donuts, is in the numerator or the denominator. It doesn't particularly matter. You just need to make sure that you're sort of matching it and keeping them in sync. That's the big thing, right? As always, we're just going to cross multiply to solve it. So 2/3 of 25 equals 10 times x. And then, of course, to get my x, I'm going to do a division by 10. So I kind of end up with here, if I take all this together, this is sort of 2/3 times, 25 over 10. Kind of playing with this a little bit. We're obviously going to get some sort of a fraction here, but that's okay. We started with a fraction. Really just the 25 and the 10 here that are going to reduce, right? This would be kind of like 5 and, oh no, I said that, but that's not true at all. 5 and then these 2's would go. So it looks like this is going to be 5/3 cups of sugar, right? So 1 2/3 cups would be my x here to kind of scale this up. So, all this stuff works, is sort of totally fine. The other thing you can do where you sort of might see this if you've ever looked at a map, I think this is still true in Google Maps, but you can also have so scaling on a map, right, where you have 1 inch is equivalent to x number of miles, for example, right? So you can kind of measure in inches your distance on the map and then sort of scale that up into sort of miles in real life. So say, for example, we've got, 1 inch scales up to 3.5 miles on our map. And so then the question is, okay, how far will 9 inches on the map be in reality? So all I'm going to set up, right, is, so 1 inch gets me 3.5 miles. And so then if I've got 9 inches that I'm measuring, that's going to get me kind of x many miles, right? And again, I can kind of play with the setups here. You can even play around a little bit. You could do sort of 1 inch to 9 inch and then compare 3.5 miles to x miles if you want. I mean, in theory, that also works. I think for me, it's easier to just say, okay, this is kind of situation 1 and this is situation 2, and then you just sort of match your units or your scenarios, in this case, kind of inches to inches and miles to miles. That, for me, kind of makes a little more sense. My cross multiplication here, right, this is kind of 1 times x, which is x, is going to be 9 times 3.5. What's that going to be? 9 times 3 is 27. Times 0.5, half of 9 is 4.5. 27 and 4.5 would be 31.5 miles. Right. That one maybe is a little obvious, right? If your sort of key is sort of a unit rate in some sense, 1 per, 1 inch per however many miles. If you go 9 inches, you're obviously just going to multiply your miles by 9 to get there. The point is not so much maybe that you could kind of do that without thinking about it. The point is that the way you would sort of set it up as a proportion is consistent with all the other ones that we've done. So, right, if you can kind of get this and kind of reason it out, you can then, in theory, kind of backtrack and maybe work out the other ones too. But that's the deal. So that's some proportion applications. We're going to sort of continue working with this sort of proportion, and some of the ratio stuff is going to kind of keep coming up in this chapter and in chapter 7. So all this stuff is going to sort of hang out and stick with us for a little bit. So make sure you're comfy with it, because it's not going anywhere.